Previously and recently, we've been talking about 95% confident. I'm 95% confident that the sample mean or the population mean will be in this interval. But what does it really mean to say that I'm 95% confident about something? That's what this page will show us. We have previously discussed the meaning of the term 95% confident, but this probability statement is often misinterpreted, so we will revisit it again now. We will use the applet below to randomly select a sample from the population with mean mu and a standard deviation of sigma. For each sample, the applet computes the sample mean and shows the associated 95% confidence interval. When the applet loads, you will see a normal shaped distribution, which represents the sampling distribution of the sample means, in other words, x bar. The green line marks the value of the population mean mu. To begin the simulation, we'll click the sample button on the left at the top of the applet, not the sample 50, just the regular sample button. You'll see a single horizontal line segment appear underneath the distribution with a tiny red dot in the middle. The red dot is the x mean or the x bar value. The line segment represents a confidence interval, so all the values in the interval are estimates of mu. Let's go ahead and do that now. We'll scroll down. You should try it as well on your own, but you can see it in this video. I clicked sample. So this is all the mu's, the estimated mu's, because this green is the real mu. So the red, the single line segment appearing underneath the distribution with a tiny red dot in the middle, the red dot is the x mu value. So in one sample, I got an x mu it seems like it's quite a bit off from the actual mu. Here's x bar over here, but that was just from one sample. The line segment represents a confidence interval, so all the values in the interval are estimates of mu. Okay, and this represents a confidence interval, so mu is within there. So this is our estimated mu. We don't know necessarily if that's the right one, but our confidence interval is from this to this, and the actual mu you see is actually in there. So we were correct on that one, at least in this case. Work with the applet to answer the following question. So let's see. The first question, we'll click sample. We did that already. Did the resulting 95% confidence interval contain the population mean? Yes, ours did when we did it in this video, but yours, if you do it, it might not because it's a random sample. But in this case, it did, but it wasn't super close to the middle of our interval. It was off to the left, or sorry, to the right. If your confidence interval contains the population mean mu, the green line will go through your confidence interval and the applet will record one hit at the top, quote unquote hit. Otherwise, the applet will record 0 hits, quote unquote, at the top. Now click sample again to select another sample. Is your second sample mean x bar, i.e. the new red dot, the same as the first sample mean? Does the new interval contain the population mean mu? Let's go check. Okay, let's try this again. I'll press sample. Well, yeah. So another sample has been taken. You can kind of see it below. Let's see. This red circle was our old sample mean. Our new one's a little bit larger, a lot closer to the actual mu here. But our new confidence interval is that horizontal line, the newer one that's lower, just barely lower. You might not be able to see it in this video very well, but when you do it on your own, you'll see it better. So this, you can tell this confidence interval is much better. It's mu, the actual mu is closer to the actual center of this confidence interval. Mu is inside of it, and it's really close to the middle. So, okay, that's a good sign. Let's see. So we can answer their question. They said, does the new interval contain the population mean mu? Yes. And if you do your own, it might not be the case that it does. The number 1 and number 2, either of them might be no, or both of them might be no. But both could be yes. But we had yes for both. Okay, now we'll click sample 50 repeatedly until the applet tallies a total, quote unquote, of around 1,000 samples. Note that the applet has computed the percent hit, quote unquote, for all the 95% confidence intervals. A hit is a sample mean x bar with a 95% confidence interval that contains the population mean mu. In the large number of samples, what percentage of the 95% confidence intervals should contain the population mean mu? We anticipate that about 95% of the confidence intervals will contain the population mean, 5% will not. 5% just coming from 95%, taken away from 100. 100 minus 95 is 5. The 5% of the intervals that do not contain mu appear as the red line segments. So let's go try that now. Let's see. I'm going to press that sample 50, as they said. We haven't done that yet, but I'm going to do that until I see think I'll reset it. Okay, I'm gonna do that until I see a total of 1,000. Let's see. So I see here total intervals, they're only 50. I'm gonna keep pressing sample 50 until I see that become 1,000. Almost there. There it is, 1,000 intervals. Okay. So it says that there were 945 hits out of 1,000. 5 out of 1,000, which is another way of saying 94.5% of the time we had the right one. That's pretty close to 95%. So 95% confidence does seem about right, at least from the work we did here. And if you do your own, it might be a different number, just based on random sampling, just based on chance. Yeah, it's not something you did wrong or I did wrong. So what's the main point here? The phrase 95% confident means that in the long run, repeated random sampling, 95% of the confidence intervals will contain the population mean. When we calculate a confidence interval, we do not know if that interval contains the population mean, but we can say that the methods we are using to find confidence intervals will be accurate 95% of the time, i.e. will generate an interval that accurately estimates mu. This does not mean that there is a 95% chance that mu is in the particular interval we calculated based on an observed sample mean. Why? Once we hit sample and we got the interval, it either contains mu or it does not. However, before we hit sample, we can say that there is a 95% chance that the next interval will contain mu. This is a subtle but important distinction, and it is hopefully clear after working with this applet. Yeah, so they're just saying that if you haven't hit sample yet, you have a 95% chance that mu will be in your confidence interval. But after you hit it, then your confidence interval is already decided. So there's no longer a 95% chance because it already exists and it's already a certain interval. It might be way off from the mean, it might be actually close to it. So it already exists. I can't use the 95% chance yet or anymore, only before I press the sample.